Okay, so here we have what's called the Aufbau principle. And it says that an electron occupies the lowest energy orbital that can receive it, okay? And what that basically means is if you were drawing an atom, here's your proton. So its nucleus just has one proton. That means that it's hydrogen, right? So it's hydrogen, and then the question becomes, all right, where do we put the electron? Do we put it in the first energy level, the second energy level, the third energy level? Well, what they've found is that the electron will exist on the lowest energy level that can have it, all right? And that's what this principle talks about. So that one electron is going to hang out on the first energy level, all right? Now, if you give it energy, it'll jump up to the higher energy level, like we've seen before with light and whatnot, and then it'll jump back down and give off a photon. But that's not what we're talking about. We're talking about generally, where are the electrons going to be? And they're going to be in the lowest energy level or orbital that can receive it, all right? Then there's also Hund's rule, which orbitals of equal energy are each occupied by one electron before any orbital is occupied by a second electron. All electrons have the same spin, which is up. All right, now this part gets a little bit weird, but when we get into electrons, think about the p orbitals, right? There's three different kinds of p, right? There's the x, the y, and the z. So if these are all p, they all have the same amount of energy, all right? And you can kind of think of this as if you were to get on a bus, all right? Here's our wheels. Here's me, I'm driving the bus, all right? And then you get on the bus. Where are you gonna sit? The first seat, the back, does it matter? No, because you're first, right? So Tiffany is gonna get on, and when we represent electrons in here, we're gonna have them as single-headed up arrows for right now, all right? So Tiffany gets on, she sits in the back by herself, all right? Now, Paris gets on the bus. Where is she gonna sit? In the middle or front. Why? She doesn't know Tiffany that well, right? She's gonna sit, same thing as you guys when you get on a bus. You want your own seat, right? So she'll grab her own seat, and then Abby gets on the bus, and then she'll sit in the front, all right? And then each of them have their own seat, and everybody's happy, right? Electrons do this. Now why? Because they're all negatively charged, right? They don't want to be near each other. But these all have the same amount of energy. They want to go to the lowest energy possible, so they're going to start filling these up, but they're not going to double up, all right? Now here's the problem, all right? Riley gets on the bus. Riley gets on the bus, she looks around, she sees Tiffany, sees Paris, sees Abby. It's all good, doesn't matter. She'll sit anywhere. Everyone, you know, there's always one person in those seats, so she'll go in there, and maybe she'll sit next to Tiffany. All right, because everybody likes it in the back of the bus. Now this is a down arrow, all right? The reason for that is the electrons spin in opposite directions. Yeah, I'm not gonna edit that out. You can enjoy my squeak. So the electrons are all kind of going in one direction, and then the second one goes in the opposite direction to kind of balance things out, okay? Another person gets on the bus. They just, oh, not up, you have to go down. And then another person gets on there. And then once all of these are filled, because remember, each orbital can only have 2 electrons, so now these are filled, then it'll start filling the next energy level higher up, or the next orbital higher up, all right? So that's what's happening in there. So electrons will come in, they'll go to the lowest energy level first, they'll try to stay by themselves, and then they'll start to pair up, all right? Now what is this actually gonna look like? I'm glad you asked. Okay, so here are the rules. A single-headed arrow is an electron. First, you put an up arrow, all right? One up arrow per box. If you have groups of boxes, each can have one, all right? And then you'll start doubling them up. So you notice with the S's, there's no options, right? As soon as you put one electron in there, and then somebody else, you want to add another electron, it has to go into that box. It's not going to go into this box because it's going to take more energy, right? And remember, one of the rules is it goes to the lowest energy level possible. The other rule is it tries to fill these up individually, all right? The first time where we get options are with the P's, because then you can fill them up 1, 1, 1, and then 2, 2, 2. You can fill them up that way. And with the D's, you get more options, and the F's, you have more as well. It's kind of like the bus just keeps getting bigger and bigger. All right? Good? Okay. Now, a couple things. When we're doing this, we want to think about, all right, what's actually happening here? Now, in this chapter, we're going to just assume that each time we put an electron here, we're also putting a proton in the nucleus, because we want to keep it neutral, okay? And again, this chapter, we're really just focusing on the electrons. So right now, we have one arrow. That means we have one electron, which also means we have one proton. So this is what hydrogen would look like, okay? It has one electron, one up arrow, and that's kind of it. All these other energy levels are empty, okay? Now, let's say that you wanted to do helium, all right? How many protons does helium have? It has 2. So now that means we need 2 arrows. So we already have one arrow here. Where would we put our second arrow? Same box next to it, aim down, right? So all these things we would need to do, because you wouldn't put it up here because it takes more energy. And again, we want to put it in the lowest energy possible. So this is what helium would look like, okay? Now let's look at it as an actual atom. If this is the nucleus, here's the first energy level, and it has 2 electrons. And that's what we expect to see, right? It's just nucleus, 2 electrons, everything's cool, first energy level, right? Now let's say we want to make the next element. What's the next element? Lithium? Yeah. All right, so we have lithium. It has 3 protons and 3 electrons, right? If we were to draw lithium the old-fashioned way, we would need another energy level, right? Because the first energy level can only have 2, all right? The second energy level can have up to 8, right? All right, so we're going to put that 1 electron on the second energy level, and now this is lithium. 3 protons, 3 electrons. How do we represent it over here? Yeah, we need another up arrow in the 2s, right? What do you think the 1 represents? And the 3. Yeah, those are the energy levels. All right, so those are the energy levels. And then the letters are your orbitals. And sometimes you have suborbitals, which is just there's multiple orbitals. All right, so there we have lithium. All right, what's the next element? Beryllium, 4, right? 4 protons, 4 electrons. If we go back to our drawing of the atom, we have 1, 2, 3, and then we need 1 more, right? All right, so 1 more. And then we would draw it as a down arrow over here. All right, everybody's cool with that? Now we're going to get into some molecular geometry stuff later on in the year and how this will actually look a little bit different when there's bonding and stuff. But for right now, let's just kind of think of this as how many electrons do we have in each energy level, okay? All right, now, this was beryllium, right? What's the next element? Boron, all right, boron has 5, right? 5 protons, 5 electrons. Where do we put our next electron? Where do we put our next electron? 2p. Yeah, in 2p. So this is kind of Tiffany getting on the bus, right? She has all of these options. She can sit right here. All right, that's fine. And then for our drawing, we're going to put it somewhere else, right? And you could almost think of this drawing as having those boxes on there as well. For example, this would be the S boxes. There's a P box over here, another P box, and another P box, if you will. All right, so then we have to start filling these up. All right, that was boron. What's next? Carbon, all right. So then we have carbon. Carbon has another up arrow here. It gets an electron, all right. And then if we keep going after carbon, nitrogen. All right, so then we get nitrogen here. And then what happens after nitrogen? Oxygen. So where does this go? Does it go up to 3s? Does it stay in 2p? Finishes, yeah, 2p. Now you have a down arrow, right? All right. So that would be our nitrogen. What's after nitrogen? Was that nitrogen? No, that was oxygen. I'm sorry. Then we have what? Fluorine? All right, fluorine. get another one. Oh, I forgot to put a dot there. There we go. 1, 2, 3, 4, 5, 6. All right, so fluorine is going to have our 7. Fluorine's going to have 7 there. And then last but not least, we have neon, right? And then neon would have 8 here. And then it actually has 8 in the second energy level too. If we kind of divide this up by energy level, there's 2 here, and then there's 6 here, and that'll give us a total of 8. Okay, any questions with that? No, you guys okay? Does it make sense? We're just kind of adding them? Okay. What is sodium gonna look like? What would we do to this to make it sodium? Yeah, next energy level, we get an up arrow, right? The 3s. And then this needs to get a little bit larger. And then we need to put in another dot there. Okay? And then we just kind of keep going. So if that's sodium, what's the element after sodium? Magnesium? Mm-hmm. So then that would be a down arrow here. After magnesium, it jumps across to aluminum. All right, so we have aluminum, and then the next one, and then the next one, and the next one, the next one, and the next one. All right, so up, 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 down, 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 right? All right, what element is this, the one that we drew now? Where all the 3s are filled up. Well, all of these 3s are filled up. Argon. Yeah, it's argon, right? Now, how many electrons does argon have? 18. To check, we just count. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay? So you're always keeping track of everything. All right? And then if we wanted to do like gold, how many electrons does gold have? 79. Yeah, too many, right? But you would just keep doing the exact same thing. You would just keep going and going and going. Now, we're at an interesting spot though. We're at 18. You said it was argon, right? What's the next element after argon? Potassium. Is that in the S's or is that in the D's? It's in the S's. So check this out. Even though these look kind of similar, you're going to go to the 4 S's, right? Because they have lower amount of energy. As we're moving up, that's increasing energy. So we're going to go to potassium because it's in that 4S. After potassium, we're going to go to calcium, right? All right. And then after that, notice what the next one is after calcium. What element is it? Yeah, it's SC, scandium, and that's going to go over here. So now we're going to fill up the 3 Ds. Okay? Everybody cool with that? Now, where is this actually happening? What's actually happening here? If we were to look at this, here's our nucleus, first, second, third, fourth energy level. When you put these 2 down, these 4 S's, they're here. When you do this one, this electron actually goes into the 3rd energy level. All right, that's why the 3 is there, because it's telling you what energy level you're putting it into. So not every electron that you put down is a valence electron, meaning it's not always going to be in the highest energy level. Okay?